All right, in this case, we have a scheduling problem where we have a list of employees and a list of jobs that need to be done. And the table is just giving an estimated amount of hours that each employee would take to complete each of those cases, or in this case, these are lawyers and they have to work a case. So what the scheduler wants to do is, based on this information, decide which lawyer gets which case in a way that will minimize the total hours expended by the firm. In this case, to be efficient. So the last line of the problem is saying determine the optimal assignment of cases to lawyers such that each junior partner receives a different case and the total hours expended by the firm is minimized. Well, the idea is each lawyer is going to be assigned a single case. So what we're kind of looking at is what each variable should be is basically a integer, either 0 or 1. All right. So it's representing, for example, x11 will represent kind of whether or not lawyer 1 will actually be working case 1. So if x11 is 0, then lawyer 1 will not be working case 1. But if x11 is 1, then lawyer 1 will be working case 1. So what is the idea here? What is the cost going to be? Once we assign all these zeros and ones, we're going to basically see that the numbers in this table of hours times that 0 or 1 will be an amount of hours that will be worked on a case. So if we add all those up, that's going to be the total hours expended. So in this case, we just sum over all possible variables, each of which is either a 0 or a 1, times these numbers. So we have 145 times x11 plus 122 times x12, because x12 refers to lawyer 1, case 2, 130 plus x13, and so on throughout the table. So all the variables which are x1 comma something are the decisions of yes or no for lawyer 1 on each of the 5 cases. And then for lawyer 2, all the variables which are x2 comma something are going to be the yes or no values of whether or not lawyer 2 is working on each of the 5 cases, and so on. So the point is, in the end, our assignment would look like a matrix like this, where we would have a bunch of zeros and ones in the table, the 1 showing which lawyer is working on which case, the 0 saying which lawyers are not working on those cases. The problem is each lawyer has to be given a single case. So that means there's only going to be 5 ones in this whole thing. But we have to make that decision. So the constraint is, if I add all the zeros and ones for each row, they have to add to 1, because there's going to be a 1 somewhere where 1's going to work one of the cases and not work any of the others. So those numbers have to add up to 1. All the numbers x2 comma something have to add up to 1, because again they will all be either a 0 or 1, and only one of them will be a 1. And then the same thing for lawyer 3, 4, and 5. But at the same time, each case has to have a lawyer working on it, and only one lawyer working on it. So all the variables which are x something comma 1 have to add up to a 1 for column 1. All the variables x something comma 2 have to add up to 1. All the variables x something comma 3 have to add up to 1, and so on. And that's what this notation here in the solution is saying, is the first one's saying if I sum overall lawyers, their decision yes or no as a 0 or 1 for each of the 5 cases, that has to be added up to 1. And the second constraint here is saying if I sum overall cases, j from 1 to 5, for each lawyer, I equals 1 to 5, those have to add up to 1. And then all we're saying is all variables are non-negative and integral. Well, that implies that I have a bunch of variables which are non-negative integral. These two conditions above, for those to be satisfied, the only values that can be are zeros and ones. and that's consistent with what we want. Now, a more general way of doing a problem like this would be to, and this is what I may have mentioned, I kind of made it more complicated when I was explaining it. I did that incorrectly, so I apologize. The question could be to assign amounts of time or proportions of each lawyer's time to each case. So you could have a bunch of lawyers working on a case, each working a certain proportion of their time availability. We would need a little more information to do that, but you could do the same kind of thing. You could assign proportions of lawyer one's time to case one and so on to all the other situations. And then you'd still have to add up those variables, add up to 1 for each row and 1 for each column. But in this case, it's much simpler than that. The decisions are just going to be yes and no for each lawyer case combination, and we can only say yes 5 times. Each lawyer has to do a case, and each case has to be done by 1 lawyer.